Hello everyone, I'm Perera A.S.A. and I'm going to start our presentation by walking through 8 key vulnerabilities we identified in this project. These vulnerabilities, these vulnerabilities, if left unresolved, could have serious consequences for this application, and I will explain how we address in each one to improve the security of the system. So, to analyze our project, we use SNCC and SAP like tools for identify each vulnerability. So, let's talk about our first vulnerability. The first vulnerability we tackled was information exposure. This vulnerability occurs when sensitive information about the system is unintentionally exposed to potential attackers. In our case, Express.js framework was revealing the expowered by header in the HTTP response. This header was advertising that we are using Express.js framework, which is vulnerable information for attackers. Why is this dangerous? When attacker knows framework or technology stack being used, they can look for specific vulnerability associated with the version of the software. For example, if an attacker knows that we're using Express.js, they can search for known exploits or weaknesses related to the framework, which increase the risk of targeted attacks. To address this, we implement a security middleware called H.R.A.L.N. H.R.A.L.N is a simple yet powerful middleware for Express.js that help secure the app by setting various HTTP headers. One of its default feature is disabling the expowered by header, which prevent attacker from learning about the server's technology stack. Also, we took advantage of other security features provided H.R.A.L.N, such as X framework option, X content type option, and strict transport security. Moving on to the second vulnerability, regular expression denial of service or RDoS. This type of vulnerability occurs when attacker use a carefully crafted input to exploit the way to regular expressions are processed in our code. Regular expressions are a powerful tool for pattern matching, but if they are not written efficiently, they can cause excessive resource consumption when processing the certain input. This can lead to significant slowdown or even complete crash of the system, which is especially dangerous in production environment where uptime is critical. In this project, this vulnerability was introduced through dependency, especially in SendVer package, which came through Node.1 2.022. SendVer package had efficient regular expression pattern that could be exploited in RDoS attack. To fix this issue, we upgrade Node.1 to version 3.00, which removed vulnerable version of SendVer and include optimization that address efficient regular expression. This upgrade ensures that our system was no longer vulnerable to RDoS attacks via this dependency. So this is my part. Now I'm going to invite Sahan to continue our presentation. Sahan?
Hi everyone, I'm K.S.V. Perera, IT21026898 and for this project I have identified two vulnerabilities. First one is cross-site scripting. So what happened in here is an attacker can inject malicious script using JavaScript to the web pages that the user is viewing. So the impact of these vulnerabilities, the attacker can steal the session cookies and the tokens, and even they can steal your sensitive data as well. So to mitigate these, we can sanitize the user input. So for that, we have used dump purify dependency. As you can see, previously it's directly feed into the source attribute, but now we are wrapping the value using DOM purify sanitize. So with this approach, we can mitigate this cross-site scripting vulnerability as well. So for the next vulnerability, I have identified this prototype pollution. What happened in here is an attacker can manipulate the object. An attacker can change the object's prototype. So if that happens, it will affect all the instances of that particular object type. So to overcome this, to the impact of these vulnerabilities, it can lead to some system crashes or even remote code executions and logic bypasses. So to mitigate these, we can properly validate the user inputs by the properly validate the objects by checking if it has the key, if it has a key using this has-on property method. And even we can check the data type. for that user inputs, and properly handling the errors. So we have enhanced the error handling in this project as well. So with this approach, we have the results. So we have overcome these two approaches. So next, I will hand over the session to my next colleague.
And I'm going to talk about the two vulnerabilities that I've identified and their fixes. The first vulnerability that I've identified is the cross-site request forgery. So that was the first one. In order to identify these two vulnerabilities, I have used SAP and SNCC tools. The first vulnerability is, as I said, is the CSRF. So CSRF is basically a vulnerability where a website tricks the user's browser into making an unwanted request to another site where the user is already authenticated. The impact of this vulnerability are modifying user data, perform unauthenticated transaction, delete and alter resources. So in order to mitigate those vulnerabilities, I have first installed the CSRF middleware and then enable the protection CSRF protection in server.js. So this was the code before and after wrapping the code with CSRF protection. So this was the screenshot which is included in my documentation, which includes the output gain through using the tool SNCC. So this has indicated that there's a cross-site request forgery identified in server.js. So after following the before steps, the error was mitigated. So the second vulnerability that I'm going to talk about is the X content type option header missing. So talking about this vulnerability, it occurs when the website doesn't include the X content type option header in its HTTP request. So the potential impacts are cross-site scripting, execution of harmful scripts, and increased risk of MIME type confusion attacks. So in order to mitigate that, I have used this code snippet in my server.js. So I have added X type content type options header with the value no sniff to ensure that the browser trusts the MIME type declared by the server. So this tells the browser to sniff the MIME type and trust the content type header specified by the server. So this error was identified through the SAP tool. So a report was generated through the SAP tool, and this indicates the error that I have identified. And showing you the code, this is the part that I've used CSRF protection part, and this includes a part where the X content type option header middleware was used. So that is all about my vulnerabilities and my fixes. The next vulnerabilities will be explained by Jani. Thank you.
Thank you, Rajani. My first vulnerability is username enumeration. Username enumeration basically happens when an attacker is able to enumerate the username, or in this case an email, of the user. So this basically happens due to distinct error messages or success messages as like this. So in this case, it first finds the email is existing or not, and if it doesn't exist, it gives this specific error message as to admin doesn't exist. So the error attacker can predict if this certain email is registered with the system or not. But on the contrary, what should happen is in each case we should give a generic error message. So in this one, I have used the same error message that was earlier given to invalid credentials or incorrect password for the non-existent email as well. So the next vulnerability is the missing anti-click checking header, also known as X-frame options. This is not set in the application. This leaves the app vulnerable to click checking attacks, and click checking allows an attacker to embed the app in an invisible iframe and trick the user into clicking buttons or links they can't actually see. This means that the attacker is able to manipulate the user actions and perform unintended tasks. So to prevent this, what I have done is adding the extreme options header with the deny or same margin values. In this case, I have used deny. This will actually stop the application from being embedded in iframes. So in our environment, which is the Express.js, we can easily do this by adding middleware to set the header. And my next part is the OAuth implementation. So this is the Google Cloud Console. The ID that I have added is VAPT Central Across, and you can see we can log in with Google, and it goes into this consent screen. You can select the email. This is the same ID, and continue, and it will be redirected into our application. So this is the flow that I have just explained, and this is the backend code. I have used passport strategy along with Google OAuth 2, and use the client ID, client secret, and this serializer and deserializer to maintain the session. That's all for the VAPT fixes, vulnerability fixes, and the OAuth implementation. Thank you.